Hello everyone, welcome to Secure Cyber-Physical Energy Systems and Data Science Laboratory. My name is Dr. Prakash Ranganathan, Assistant Professor at the School of Electrical Engineering and Computer Science. And this lab is, we do play with a lot of data. This does not have any safety concerns or hazardous things, It's mainly a computer-based labs. We do a lot of forecasting, simulations. We play with a lot of big data sets and we manipulate data. We also try to understand the interpolation techniques, the missing data. So anything that has to do with data and software, because we're interested in creating a meaningful software that uses, that mines big data techniques. Also we also do cybersecurity stuff in this particular lab. Here's an example where we are interested in developing a UAS swarm technology, where we are customizing, building our own drones using combination of Raspberry Pis and our own autopilot controllers that we are building for a counter UAS operations that can be helpful to detect harmful drones that are actually going after this airport or power grids. So according to Homeland Security, it's important for us to make sure to develop some technologies to detect these so-called threatful drones. So we try to develop mitigation solutions to identify how to detect them and safely land for appropriate investigations. And then we also play with a lot of power grid data sets, especially anomalous signatures. We have a couple of smart grid projects that we are actually working on, funded by National Science Foundation, where we are interested in actually mine the fault patterns. How do we detect different types of faults to minimize the outages? Outages are still common in power area, but especially weather is being an important element. So how can we look at weather parameters, also look at load forecasting, demand forecasting, to do an accurate predictions. So we're also interested in actually doing forecasting operations and simulations in this particular lab. And moving on, we also have another continuing of the same laboratory where we also do, we have several graduate students working on this lab and postdoctoral researchers. And we're also interested in developing a lot of visualization methods for advanced data analytics operations, as part of AI research. So we have here's an example of currently we have a soybean research project that's going on where we are collecting multispectral and hyperspectral images to detect something called soybean cyst nematode. It's a plant disease in soybeans, so we are which is affecting yield a lot. So we are interested to make sure to see how hyperspectral images along with the ground truth variables can help us to find these hot spots in our farms to make sure that farmers can able to maximize the yield and minimize this disease management process. And also we have another project on thermal imagery with reference to buildings, where we are interested to quantify energy audits in buildings as well. Again, that also involves working with large number of data sets to look at the object detection in terms of, for example, in a building you have windows, doors, facades. How do we accurately identify them using combinations of, both the building geometry as well as the thermal imagery what we actually capture using UAS. So my students in this labs actually focus mainly on creating a meaningful software environment or software where we actually use these data sets. Thank you for your time.